today we're going to talk about finding slope by using the slope formula, and we're also going to look at converting equations from standard form to slope-intercept form. So let's start with a quick review of slope. When we're talking about finding the slope of the line, we're talking about the steepness of the line. So here I have two linear functions represented by these lines on these graphs, and we've been asked to find the slope of the lines. So whenever you think of slope, we should think rise, our change of y values, over the run, the change of the x values. So looking at these two graphs, we'll start with the one on the left here. To find the slope, first of all, decide, is this slope positive, negative, undefined, or zero? Those are our four options of what our slope could be, and then we can actually find the numerical value of the slope. So for this one here, I'm going to start, they gave us some nice points to begin with. When I say nice points, I mean points that have integers for their ordered pairs. So this would be like 0, 5, and 3, 3. I consider those nice points where my axes are meeting there. So I can count rise over run. So if I start at the point 3, 3, I'm going up 2, and I'm going to go to the left 3. So when I go up 2, think of that as going positive 2, but then when I'm going to the left 3, that's a negative 3. So my slope for this line is positive 2, my rise, over the run, negative 3. So that's going to be a negative 2/3 slope. Now, if I had started at 3, 3 and decided instead to go down, I could have done that as well. I would have gone down 2 spots, so it would have gone down negative 2, and to the right 3, so that would have been a positive 3. And notice that my slope is still going to be the same thing, so it doesn't matter where you start from which point or which direction you go into, because either way you'll get the same slope. All right, let's look at this next one. So this one, I can see 2 points that are kind of bolded, but I'm really looking to see where do I have nice ordered pairs that are integers. So looking at this point right here, my y-intercept, I have a point 0, 3. And this point over here, my x-intercept, I've got 4, 0. Whole number, nice integer points. So same thing, let's count our rise over our run. So I'm going to start at 0, 3 this time. I'll go down 3. So my rise, even though it's going down, is negative 3. So y values are our rises on top, so negative 3. I'm going to the right 4 spots. So positive 4. So my slope for this one is positive 4. There you go. That's how you can find the slope graphically. We can also find slope algebraically. So in your notes, I would go ahead, pause the video, write this down. For any 2 points, so any 2 ordered pairs, x1, y1 would be the first point, x2, y2 is my second point, I can find the slope using this formula. Rise over run again, so our y values over our x values, y2 minus y1 divided by x2 minus x1. And when you start looking at ordered pairs, you might ask yourself, well, how do I know which one's 0.1 and which one's 0.2? I'm going to go back to the other slide for a second here. Remember, it didn't matter. Either if I decided this right here was 0.1 and this was 0.2, or the other way around, with this being 0.1, this being 0.2, it didn't matter. So you get to pick, but whatever you're going to do, be consistent about it. And I'll show you what I mean in this next example here. Go ahead and write this down in your notes, 2, 5, 8, 1. And if you remember doing this before, go ahead and see if you can do this on your own. Pause your video and work ahead, and then click resume and see if we get the same answer. So for my first point here, I have 2, 5, and 8, 1. So I've got 2 points, and we can decide which one's 0.1, which one's 0.2. It doesn't matter. Either way, you should get the same slope as long as you're simplifying correctly. So just to throw things off a little bit, I'm going to say this is my first point, and this is my second point. Now, if I go through y2, my slope formula, y2 minus y1 over x2 minus x1, let's go ahead and set that up fully. This is what showing your works look like, and this is what the expectation is going to be for your homework and for your check-in and for your test, is that you're actually showing your work to support your slope answer. So y2 would be 5 minus y1, 1, all divided by my x2. So because I started with 5, I have to start with the x value that went with that. So 2 minus 8. go ahead and simplify this. 5 minus 1 is 4. 2 minus 8 is negative 6. And looking to see, can I simplify this fraction so that it's in simplest form? Well, 2 goes into both 4 and 6, so I end up with a slope of negative 2/3. Now, if I had switched this around and instead said, this was my first point and this was my second point, so if that was true, I would have done 1 minus 5 over 8 minus 2. That would have given me 4 over, right, negative 4 over 6, which still simplifies to negative 2/3. Either way, you'll get the same answer. The order of the points, which one's x1, y1, which one's x2, y2, that doesn't matter. All right, last example here for finding slopes algebraically. Now, I highly encourage you at this point, pause the video, work through this one, even if you didn't for the first one, and see how you're doing. See if we have any misconceptions or if we have anything else that we need to work on. So let's go x1, y1, x2, y2. Got negative 7 minus negative 2 all over 4 minus 0. Well, when I simplify this, negative 7 minus a negative 2, when I'm subtracting the negative, the same thing as if I was adding 2. Going through and simplifying this then, negative 7 plus 2 is negative 5. 4 minus 0 is 4. Looking to see if I can simplify that. Nothing goes into both 5 and 4, so I will leave my answer like this. This would be my slope. Double checking to make sure your y values, your rise is on top, and your run, your change of x values, is in the bottom. So y is in the numerator, x is in the denominator. All right, our second learning target from today is to convert from standard to slope-intercept form. And this is going to come up a lot throughout this unit. So let's take a look at what slope-intercept form is. Slope-intercept form is when we have an equation written like this. Y equals mx plus b. Now in this equation, x and y, that's just like any ordered pair that we have that would be on the line that this equation is representing. So it could be like x1, y1. M, that is representing our slope. And B, this is representing our y-intercept, where our graph crosses the y-axis. Now, the really nice thing about having an equation written in slope-intercept form is it's super easy and quick to identify your slope and your y-intercept immediately, which is very helpful when you're graphing. So, let's take a look at a couple equations that are not written in slope-intercept form and see if we can convert them to slope-intercept form so we can identify what our slope is. Number 1, please put this equation in slope-intercept form. So currently, this equation is written in standard form. I know that because my x and my y are on the same side of the equation together. To convert this to slope-intercept form, really what I'm trying to do is I'm trying to get y all by itself on one side of the equation. It should look something like this when we're done with it. So we're just going to use our algebraic properties to do this. So looking at this equation here, 8y minus 4x equals 8. I'm going to start by adding 4x to both sides, trying to get that y term by itself. Using my addition property of equality, I can add 4x to both sides to simplify this. So I'm left with 8y equals 8 plus 4x. All right, using my division property of equality, I can then divide both sides by 8. And if I divide the left side by 8, I have to divide each term. Everything on the right side is getting divided by 8. I'm not picking and choosing. Everything has to get divided by 8. So when I simplify this, I'm left with y equals 8 divided by 8 is 1. And 4 over 8, well, if you type that in your calculator, you're going to get a decimal. Let's leave them as fractions so we can look and see our nice rise over run and look at our slope nicely. So I'm just going to see, can I simplify that fraction? 4 over 8, 4 goes into both of those, so that's the same as 1 over 2, or 1/2 x. Now, the equation I just wrote in slope-intercept form, it's pretty close to being there, but using our commutative property, I know that the order of addition, it doesn't matter. So I can actually rewrite this in slope-intercept form just by switching up the order that I was adding these two terms.
y equals 1/2 x. So now looking at this equation in slope-intercept form, it's really easy for me to identify my slope. My slope is that number in front of the x, so my coefficient there, which is 1/2. That's my slope. This is my equation in slope-intercept form. Pause the video, see if you can do the second example on your own. Same as last time, I'm going to start by subtracting my x term from both sides. I guess last time I added. I added last time because it's the opposite of whatever it's looking like. So if it was a negative 4x, I needed to add it to be the inverse. This time I have a positive 3x, so I need to subtract in order to get rid of it or cancel it out on the left side, however you want to say that. So now I'm left with 4y, after these two are gone, equals -4 minus 3x. Using our division property, we'll divide both sides by 4. Same as last time, I have to divide every term by 4. And I'm left with y equals -4 divided by 4 is -1. -3 over 4 can't be simplified, so we'll just leave that as -3/4 x. And let's go ahead and clean this up, rewrite this so that it looks more like slope-intercept form. My negative or subtraction symbol needs to stick with the term it's in front of. And same thing for the -1 there. So looking at this, I can see that I have a slope of -3/4. My y-intercept is -1. It would be really easy to graph this equation now. Not as easy when I'm looking at it in standard form to identify my slope and negative. All right, that is your notes for today. Please make sure that when you're working on your Delta Math homework assignment tonight that you are showing your work for everything you're doing. So when you're finding slope, show your work for rise over on y2 minus y1 over x2 minus x1. When you're showing your work for putting equations in a slope-intercept form, make sure you're showing each step algebraically. Think about if this was a proof, what would be your reason? You don't have to write your reasons down today, but you should have a reason to go with every step that you go through. For graphing, you will be asked to graph a couple lines using slope or identify the slope from graphs. What you need to do, just make sure that you can do that even if it isn't on Delta Math as well. So if you want to get a rough sketch of your graph in your notes, I think that would be a great idea. All right, that's all I have for you today. Get working on your Delta Math assignment, Unit 3A, Day 1. At this point, we should now be able to find slope by using the slope formula and converting equations from standard form to slope-intercept form. If you have any other questions, make sure that you're reaching out to your geometry teacher.